Welcome G. Let's start. Today we are going to discuss one of the most important data structure, linked list. Okay, linked list. So first we have to discuss what is linked list and what the different set of algorithms related to that, and we are going to implement from the code perspective how we can implement this linked list. So first thing, linked list is a data structure. So the basic feature of any data structures is that they offer the capability to store the list of set of items, set of data, set of objects. Okay, they are, so this is the one feature of any data structures, offer to holding the storing set of values, and also offer capability to get those values which are stored. So data structure is a one mechanism through which we are storing our element in a particular manner so that in future we can get those data as well as. So last we also discuss about the one of the basic data structure, array. Array stores your element in a form of your indexes. Index 0 position data, 1 position data, 2 position data, 3 position data, and 4 position data. And we can get element from the array. So similarly, another data structure today we are going to discuss about the linked list. Linked list also offer the facility you can store values in the linked list and get values from the linked list. So here what the main logics behind the linked list, they are not storing data as in sequential manner like the array. So let's look the first example about the whenever we are storing data in array. Okay, so we are storing all data in sequential contiguous memory locations, and all value are assign a index like 0 position data, 1 position, 2 position, 3 position, 4 position, and 5 positions. So all data is stored in contiguous memory location. So they need a fixed size as well as. Whenever you are creating any array data structure, you have to specify the size of element which you want to create the array. Let's say array of 10 element, array of 20 elements. You have to specify the size. When you know the size of element, then we can use your array data structure. Sometime I have not idea how many number of element I am going to store. And the first prerequisite for size in the array, you must know the size of elements which you are going to store in array. Second, you must need those size of memory block, contiguous memory block. If in your computer you have enough space available so that you can create such a huge block of memory, then array data structure is okay. Let us say you want to store 10 elements in array. So in your memory there must be exit 10 blocks for storage of your contiguous memory location. All the data are in array stored one after one after one after one after one after one. So this is the two things generally we should do in array data structure. First, you have to specify the size. Second, with respect to that size, we have a available enough memory so that ki contiguous all the data can store. This is your array data structure. Now in the compared to the linked list data structure, linked list also offer the same facility. You can store element, but they don't need an initial size. Whenever you are receiving one element, just store it. Whenever you are receiving another element, just store anywhere where you have a space and make a link between these two. Whenever you receive third element, just store here and make a link between these two. Maybe you receive another request, you can store any place in your memory and just link to this. So linked list, first things, they don't need the initial size, and even they don't need kind of your contiguous memory allocation. If you have a memory available for one element, it's okay. Anywhere available, just place them and link with the previous node so that our linked list know this is my next node, this is my next element, and this is my next element. So linked list is a one way to store element in your memory and get element. Right? So there are major differences between your array data structure and linked list data structure, but here we are not going to comparing the differences between two, but conceptually know कि array data structure store all the element in the contiguous memory location with a prefixed number of size. But linked list is a use where you don't know the length of a size of your elements you want to store, and even you don't need a contiguous memory location. And all the features, all the benefit, whatever you can get from array, same you can get from the linked list. So there are some benefits of the array data structure. There are some benefits of the linked list data structure. There are some disadvantages of the array data structure, and there are some disadvantages in the linked list as well. So we will further discuss about the advantage and disadvantage, but let us look how we can do. So major decision point, what would be the decision point where you are going to use the array data structure or linked list? The first parameter, if you know the size of elements you want to store and you have enough memory available for those size, then you can use array data structure. Second, if you don't know the number of elements you are going to store, and even this is the memory effective utilizations. Linked list data structure use your memory utilization. Let us assume that in your space only you have a available space limited, okay, but not let's see this is the data field, this is data field, this is data field, this is data field. Still you have a 1, 2, 3, 4, 5 space available, then you can store 5 data, but these due to the contiguous memory allocations of the array data structure you cannot store here because you are not getting continuous memory location for holding 10 elements, but that can be possible in the linked list. So linked list use the effective of your memory. And third pointer, linked list offer fast insertion. In the case of any place you are going to store, if you want to store the first position data or second position data or third position data, so linked list quickly add value in anywhere in the linked list. But in the case of array data structure, only additions of element in the last is fast, but if you want to add the first position, a third position, a second position, this is very costly operations. Let's say you want to add 0 position data, then all the value of the 0 place, shift to the 1, 1 to 2, 2 to 3, 3 to 4, 4. We have to shifting all the values. That will a costly operation. So array data structure offer only fast insertion in the case of last data you want to insert, but the linked list offer fast insertion in the case of anywhere you want to store. Similarly, in the case of get, for accessing any element, array data structure is fast. You pass the position number third, you are getting the data. But in the case of linked list, this is a very costly operation. If you want to access the last element, you have to traverse from head to nest to nest to nest to nest, then you can find the data. So fetching data from the linked list is very costly operation when you want to access any middle element or last element. But in the case of array, it's very fast. So both data structure have some pros and some cons. But as per the situation, you have to select array data structure or linked list. So last many lecture we have discussed how to create array and how can store value array and how you can get value from array. Today, now we are going to discuss how we can implement this linked list data structure in a Java language. Let's start. So first, starting to implementation, let's think some basic things. So linked list, whatever the you are storing, okay, in this linked list, this is some terminology used in the linked list, so we should aware. The linked list like your first, this is the block, they contain two parts. First known as a which element you want to store, and second part they are storing the next address of your block. So if this block contain two parts, one part contain your elements, data parts, value parts, and next part contain your address, the next item. So this is the next block. Next block also contain the your data part and the address part, which hold the address of your next block, this next block. And this is also contain your data part and the address of your next block. Okay, whenever this also contain your data part and there is a no next element, then this should hold the address as a null. That means they are not pointing to any new block. So this, the terms block or data or element in the linked list known as a node. So this is a node. You can so in the linked list, each elements considered as a node. That node contain two parts. One part's your element parts, another part's your address of your next element. Similarly, so next again, this is the node. One part contain your element part, and next part contain your holding the next block address, next node address. So whenever we are going to implement linked list data structure, we have to use the word node. Node represent the two part. One is the element parts and next is your next node address. And sometime also linked list known as a first node of the linked list known as a header. Okay, so this is the header, and the last node of linked list known as a tail. So the terminology we are going to use: node that holding the value and next block, next node address. Header is the pointing to the first element of linked list known as a head, and a last node of a linked list known as a tail. So these are terminology you use: head, tail, and node. So whenever we are going to writing code, we are using these terms: head, tail, and node. Whenever, so in Java, whenever you are going to store more than one value. Here two value, one data value and another is the address value. Then we have to use not in a primitive way. Here you cannot use a primitive int, a float, a double. Int only store one value. They cannot store two value. So this is, you can say, one, you can create a class that hold that have two field. One field your date element part, next field your address part. So that is known as a node. Node is nothing, just is a class that have a two field, one field for your element, another field for your next block node. Okay, so let's write. So just write my class. Okay, let us class have a my linked list. Okay, and as you know, this have a each linked list have a two node. One is the head, one is the tail. So you can declare node head. So question is, what is the node? So node is a look like another class. You can say class node. A node have a two field. One your element which you want to store, and another is your next. What is the next element you are going to store? Right? Okay. So this is the node, and now we have a one node head and one node tail. Or sometime you can say this is a first node of linked list, or this is the last node of linked list. So now, okay, whenever you now you can create my linked list object equal to new linked list. So whenever you create a linked list, so at time your head and tail both are, because there is no linked list, so by default these values are initialized with a null. If you check, head, so head and tail both are the null. This is the basic rule of any Java, simple Java. We have any class and you can declare any variable. Whenever you're creating class, by default they are initialized with a null. Now whenever I want to offer some methods that can add element, so let us write method, let's void add, and add take integer element. So here you are going to add element. So let us create here node class a constructor. Okay, let's create a constructor. Okay, so now each node have element and data part. Good. So now let us write. So assume whenever first time you create one node should be created, first time node should create whatever the element you can element store here, and what is the next? There is a next, there is no element, so next would be null by default. And whenever you create one node, that means this is our head, this is our head, and this is our tail. Both are the same thing. So you can say, we can create node equal to new node, and this is the element and next to the null, right? Next is the null, or you can simply that done. So now how this head, this should be in a slice to head. So let us check here. If you check if our head is null, if head is null, then head should be your new node. Let's see your new node. Whatever new node I created, just assign new node. Let's assume what if, okay, this is the null. So, and this should be, what is the tail in this case? Tail should be the same thing. Okay, still should be the same thing. So let's assume first you create one node, that one node created, you put the element, next should be null, next should be null. Now this is your head, because your head is null, then this is the head. And then what is the tail? Tail also, this is the tail. Whenever next time you create this node, then head always should be the same, but next time tail should be this. So if you let's now again, if you just add one element, that let add, and just element I add 3, and let's after this I again check our head and tail. Let's run. So you notice that initially head and tail null, now they are both pointing to the new node. Okay, so you can say head, you can say dot. Okay, so let's now I want to add one more element. Okay, so I'll do, yeah, 2 elements, yeah, 3 elements, I'll do. If you add always head not equal to null, tail is the new node, but how make a link? This is the new node, and again this is the new node. First time it's okay, you are assigning to head and tail both, head and tail both. But if the next element you are going to add here, at that time you have to not change head is always the same, but you change the tail. So what is the tail? Tail currently this, the tail dot next, you could just assign this value. So if else part, else say if head not equal to null, then tail dot next address, assign your new node, right? New node. So let us again just add one more method, like 5. So let's write first to display the linked list, so we should know we are getting the correct value. So in this our logical scenario, what we did, we created first add element, then this is the create one new node, this create new node, whatever the element you pass, 3, we are storing 3 here, and this is your null first time, and this is assigned head assigned to head. Okay, and else not part, go to the tail, 10 assigned to the tail, the first part. And whenever you call next time 5, next time method invoke, another new block is created, element with the 5, what is the next initially should be null. Okay, then here's a head not equal to null, head is not null, then go to the else part and say tail dot next equal to new. So what is the tail dot? This is the tail, dot next, what here, link the new node, just assign to this. So say tail dot next equal to new node. So here you can assigning the new node, and again say tail equal to new node. Now this is your new node is the tail. Again you can add another element like a 7. So again you know this method. Again you create one block for element 7. You can put 7. What is the next? Next should be null. And here's a head not equal to null. Head not a null. Go to the else part. The tail dot next. Now tail is here. Tail. So tail dot next this. Assign to the new node. And now change the tail. Now this is the tail. So in this way you are adding element 1 1 1 in the linked list. So this is the one we visualize. I want to get all the elements. Just want to print first this and this. So how will print this element? How will get those elements? So we have already header variable. So you can use header and print the header value and jump to the next. What is the header next? This. Go to the next value. What is the next? Go to the next value. What is the next? Null stop. So you write a function like here, void get all. Yep, just show all value. So all element. So here say we have a node. Let's temporary. You are getting node. Let's start node with a header. Okay, and this is the temporary variable. This is the temp, and just while if temp not equal to null. Okay, that means ki header is initialize something. Okay, so you say then print system.println whatever the data dot elements, and after that just print some arrow. Okay, in this way you are printing element one by one. Let's just comment out all the things now. Let's just my dot show all elements. Okay, so let us add one more element like here 2 and just add it. So here as per our expectation this should return this 3 value. Okay, here you are looping infinite. Here you should be first element 3, then should be jump to the temp dot next. Okay, so that you can give the next and next. So your while loop should be until you are not getting null. So you are getting 3, then 5, then 2. Because we are added in this sequence element. We are added 3. So first we created 3. First we created 3, and with the null, and this is the head, this is the tail. Okay. Second time you add a 5, new node 5, and you say tail dot next. This is the link. This is the 5, and next null is null. Again you say 2. Again now this is the tail dot next. You can add new node, and this is your 2 and null. So whenever you are printing header dot get data, then next this is the get data and next get data, then next your null just stops. So in this way you can display all the elements. So is till now okay. So let us I want whenever you are add any element, let's we add 12. So by default, whenever we are going to add any element, so always they are going to append at the last. This is the behavior we implemented. Okay, so we implemented, let us do new line. Okay, so just get for each iteration the new output. So first time we added one element, first time you get one element, next time 2, then 5 and 2 last, third time 12, this is the last. So always we are adding element in the last. Okay, so if you add another element, this also go to the last. Let's add it like 6. It will go at a last position. So is it possible that we can add element, you can say first? Surely, why it cannot? So think till now what happened. You created one node for 5, then next you created a 2, then next you created a 12, then you created a 6. Till now it's okay, and last is a null. If you want to, let's add first. That means you create, I want to create like a 8. 8 should be the first. So initially, no, this is our head, this is our head, this is our tail. So you create one node, and say that this is the head, this is the head, this is become a head, and head, what is the next? What would be the next? Next should be your head. Whatever the previously head was 5, but now the head become 8. So you create one new node, this is the new node, put the value, and what is the next? Next would be your head itself, and now this node become a new head. So let's write the code. So let us write your void add first and whatever the element. Okay, so let us you say again create node, new node, whatever the element, you pass the element, and what is the next? Next you don't know, null. Okay, or you can say what would be the next? Next would be your head, you can say just head, and now say your head become equal to new node. Now you created one new node and say new node next is your head, and now head become the new node. And let's test. Here say just add dot add first, and let's element like 33, and just let's display all my elements, and you run it. So you will notice you will get this node is the first. This node is the first, and rest is your now. Right? So these are the very simplest way. The what linked list, the simple logic. Whatever you have a node, they are linked to each other. You have to maintain this linkage. A link is the contain as a part of second part of your node. So let us someone want, I want, let's get one node, or I want to add element after this node or after this node in any place. First time, always we can add last element, you done. You can add first, you can done. Now it is also possible that I want to add element between these two nodes. So I'll do. Last I want to do after this node. So here whatever the element you say, I want to add, let's in this example, we have a first 33, then 5, then 2, and then 2. Let's see, I want after 2, I want to add a new node like 3. Okay, so I'll do. So here we have to think. Let's see, someone ask after 2 I want to add. The first you find out this 2 node. Where is the 2 node? So let us example. In this case example, this is the 33, your head. Then next element is a 5. Next element is a 2. Next element is a 12. And next element is a 6. Till now this is your data. And say I want to after 2 add the new element. Not I want to add always in the last. So first you have to figure out this node, whatever the user want. So you have to figure out and you create a new node. Let's I want to create a here 3 node, and whatever this address, this contain address, whatever this next part, you can just store this next part. So this will link to the here, and now this just link to the here, new node assigned to the here. So our linked list 33, then 5, then 2, next again 3, then 12, then n. So in this way you can add node between after this 2 node. So let us write the code. How will going to add one new node after a specific data. So let us write a method like void add after. Okay, add after, and let's give whatever the element, and this is the new element. Okay, so first you have to find this element node so that you can know what is the next. First you have to, in this two questions, one is the find the node and then link to this new element. So this is your existing element, so you find the node, so you write a method that will get the node. So let us example write get node. Okay, a node element. Okay, and just you want to, so how will find the node? As you know, we have a header, you can let's a node your temp equal to head, you have a header, and you can just while loop temp not equal to null. Okay, so how to find here? You can first check header, it's match with the element, no. Next match with the element, no. Next match with the element, no. Yes, match. Then return this node itself. This is the node. So here you can say just check if your temp dot element is match with the element. If match, then return that node which match, and let's keep whole loop done, it's not match. Then what you can say? Element not found somewhere. This element, and just return like a return null. There is no such node. Might be you pass here 22. There is no 22 node. You can say this node element is not exist. So let us just invoke the get element. Okay, this is the found node. Found node. S out if found node not equal to null. Okay, and then else we have two options. Are you not found or not found? So if not found, then what you want to do? Else not found, what you want to do? Just simply say as out your element not found in linked list. Okay, so here say element, like whatever the element you have, that's element. Okay, so two options. Yeah, you let's here as out are found dot element. You found or not found. Let us just run this. My linked list dot add after. Just I want to let's keep find 2 and add after 3. Okay, and just so. And you notice till now I'm not link between these 3 node. Let's assume ki our code you are able to found this element or not. So there is nothing happen here. Somehow let's route as out found. Okay, and just stop and go to the here again problem. Here you temp nest and then temp equal to temp dot nest. Okay, whenever you are going to the find element, first getting the head match not go to the nest, not match the go to nest until you are not getting. And so in this way you can find the specific node for the given elements. So yes, node found 2. If let's someone here write like 22, so might be you say 22 not found. Okay, because there is no 22 element, so we cannot add these 3 element after that. Okay, right. So here let us example. Here I want, let's if 2 found, after that 2 you can add 3. So what you can do here, you find that's good things. Okay, then here what you can do. So let us example. Now you created a new node. Now here say node new node equal to new node and whatever the new element and comma nest. What would be the nest here? We have to think. What would be the nest here? We have to think. Let's here. So let's example in this our example. Let's see our example. First node head node is the 33. Then we have a 5. Then we have a 2. Then we have a 12. Then we have a 6. This is the way. So we say ki after found, let's keep this is the 2 we found, ki 2 is the found. So after 2 I want to add the new element 3. So here I can created the new node 3. I created new node with the new node 3. So what would be the nest? What is the nest of this node? So nest of whatever I found this node, what contain this nest point? This nest add here, so that this 3 node link to 12, and whatever this new node you can new node to add here, right? So this way you can create link. The first you create new node. So new node, what would be the nest? Nest would be this 12. But where you are getting a 12 address? This node which you found already have an address of the nest. So this value you can just store here. And after that, this value store here means that these are the link. Now you can just link this 2 with this new node, so that after 2 you are getting a 3. So this is the main logic, just changing the link. you find the node 2. Node 2 have address of your nest 12. So in the new node you can link here, right? And you can just put here. So again let's write. So here you say our nest would be not null. Whatever the found node dot next, okay, and whatever the found nodes next, you can assign the new node. So this is the logic we written. What written? So this is the 2 is the found node. 2 is the found node. 2 after that they are linking to the 12. 12. But I want after 2 should be the new 3. So you created new list, new node 3, 3. So now 3 point to the 12. So currently this 2 found node already have a nest which point to this. So I can say new node, whatever this address you can put here. So whatever the new node, just put found the nest. What is the found dot nest? 2 element nest this. So this value you can put here, so that now your 3 node link to here. And after that, so this is the new node created, and you say new node link to this here. So you say your found dot next, just write a new node. So in this way you are able to link. After 2 you can add 3, right? So let's run it. So you notice this, after 2 you are getting a 3, after 3 is 12. So let's change the header, like initially header should be, let's start with the 9, okay, first net let 9, okay, and run it. So now it's clear how you are going to add element after specific elements, okay. So first things, you find the specific node. In this example we find the 2, we find the 2 previously was the linking 12. So how can say create the new node, just link with the 12 and link to the previous node. So again just look this code after. There is a very simple code, there is no any rocket science, but just curiosity. Previously our 2 node linked with the 12 node, okay, 2 node linked to the 12 node. Now you can say after 2 I want to new one. So new you can create it like 3. Here you can create a new. But now say whatever the found node you have, whatever you have, what is the address of next node? This is the address part. What is the next part? Just store this value in the as a new element. So this is the new value. Now you are linking to the this. And now whatever the found dot next. So what is the here value now? Here value now look the latest value this. So now 2 link to the 3, 3 link to the 12, and now here 2, 3 and 12. These simple things, just visualize which link you want to change. Might be option before 3 there is a 5. These are a 5, but I want after before 2 I want to add new element like 1. Here I want to add 1. You found node, this is a 2, that's good part, but I want to store 5 and between the 2 is the new node 1. So this is a new method can be. So first thing you have to add, after 2 you can add the new node. I want before 2 I want to add some new node. The simple way how to put. Similarly what happened in the next you can change, previously you can also change. But the challenge is that here our link close, this found node don't know about the what is my previous one. They only know what is my next. So how we can find the my from found node what is the previous node? Because previous node contain the link of my 2. If I create the new node here, I have to make a linkage here. So how can do it? So let's think. Whenever you are from head, you are now 9 we have head, you are traversing from 9 to 5, 5 to 2, 2 to 12 in this way. So whenever you're traversing, why not from first you visit 9, then visit 5, then visit 2. So you already while traversing, why you are not storing what is the previous element, what is the previous node. So somehow you have to write a method that give me the found previous one. So let us example here. I want to write a method that void add before whatever the your element you pass, element and the new element. So here you have a right first, if you found node that you can found, but I want to previous one. So how we can do? So similarly look like here. Here what I do? Here one by one element we are checking this is a find or not. So look like I write another method that will not give the this node. What was the previous node? Let's write another method that give not the current node but that give the previous node. Previous node here. So what we can do? So let us again think. Currently we are starting from head. Yes, starting from head. You visiting the 9. After 9 you visiting the 5. After 5 you 2. And after 2 I'll get a. Now you 2 found. If the element is found, you returning this 2. Okay. So what? Why not we store this some previous value? Some previous value. One variable that store the previous value. And we can return the previous one. If data match, don't return this, just return the previous one. So here you can just hold one variable like a previous. And here you return the previous one if match. If not match, then before going to the next, just hold the previous equal to temp. So previous is the just behind the, now temp become the next. So in this case, here is the 9, then become your 5, then become a 2, then become a 12. Okay, that's it. Now then become a 3. Okay, 3. So let's initially whenever we start with the head. Okay, so you can get two variable. One is your temp variable, one is your previous variable. Initially pointing the both are the head. Okay, now say key element match with this 9 match with the 2 no match. Then what happens? Say you can say previous itself a temp. Okay, itself temp, but temp equal to temp next. Now temp become a temp. This is that become a temp. Now again go to the loop. Again check temp dot element. This is the element 5. 5 match with the element 2. No, not match. Then go to the here previous equal to temp. Now this previous become here previous. And now can say temp equal to temp. Now this is our temp. Again go to the loop and check match element. Yes, element match. Then return the previous. This is the previous value. Then with this is the 5 node you return. So in this way you find the previous node. Now if we found this previous nodes, just you can create again new node, whatever the new node you want, and simply add the whatever that's I want to add one. What is the next? Next should be whatever the previous node. This is the next part. You can link here and assign to the here. Now in this way you can add element after before 2. So before 2 you find the previous node. Okay, and previous node again we just link this node. How to linking? Just create a new node and whatever the value you want to 1 and just you want to link. So this 2 you want to before the before 5 is the contain the address of your 2. This address you store here and this new node is stored in this here. So in this way you can add, right? So similarly here again, now you can say get previous node. Whatever the element you have, you are getting previous node. If your previous node not equal to null, okay, not equal to null, then what? You can just create node new node equal to new node. So what is the new value? New element. And what is the next? Next would be what you found dot next, okay. And after that this new node just link to the after found node. Next would be our new node. It's done. So look like else you can give the message might be element not found, okay. Might be case ki this element not found. If you return type something value that not exist and just test it. My linked list dot add before, let's key this is the 2 element, add 1 after that and just after that just print and let's key. Now here you add 2 after 2 3, here you before 2 and 1. So in this way you can add any element before or after. Now you notice that this 2 you can add 1 before. So in this way you can add any element maybe after or first. So till now we have added new element at first. By default you can add any element in the last, or you can say ki at a specific data we have data you can add after this or before this. But sometimes someone want, no, I don't want to add element before or after. Let's say I want to keep one index. Let's see our position. I want to position number 1, 2, 3. I want to add new data here. A specific position you want to. So till now there is no any kind of position here 0, 1, 2, 3, 4. So you have to somewhere track the, let's say someone want to add element the 10th position, but there is no 10th position and there is no any kind of length here. So how we can do? So we have to logically calculate what is the your size of a list and check whatever the user want to position is under, then you can add the new node. As you already know, if this is the already linked list available, this linked list already available, if you want at this position new value, you can just create a new node and this link change to this, just change here, and whatever the address this change here. So now in this place control go to here, then go to here, then go to here, then go to here, and in the second position you are able to change data. So I'll do. So let us write another method that add yes before add, let's give void add position, add at position, whatever position want. Let's this say integer position. So first things you have to verify the given position is under my length or not. So how to check validation? So let us write one method that return the size. Let's like int size. that will return your number of elements which you have. How will find? So question, how will find the length? There is no any predefined side, but you have a header. You know, you have a header, you have a header node, and all the node are already linked to each other. So logically we can calculate the size of linked list. So we have a header. You can't start from header. You get data, increment 1, get next, increment 1, get next, get next, get next, get next, until next is null. In this way we can find the size. So let's write here, say let counter count equal to 0 and simply return count, and here say while loop, let's note temp equal to your start from header, and if temp not equal to null, then you can say like count equal to count plus 1, and you can say temp again temp dot next. So in this way you can find the size. Let us just check your integer size equal to size, and just S out what is the size. Let's write some invoke this position method. Let's say I want to add the position number 1 2 3 4 after at the 4 position. That's I want to 4 position. So it will 4 position. What is the syntax? There is position. What is the error? Okay, this is the semicolon. Okay, and you run it. So you know, till now you are able to find the position. The position user enter by its okay size. Though no say size, that's good. So let us think, if whatever the size of this, if size, okay, size is and whatever the position user pass, you can check. If the position is less than, okay, less than, then we can surely add your element. Okay, so what the element you want to add? Let's here I want to int element. So here how will do? First question, you know the position, but is it this position? Let's see example a 4. So at the 4 position 0 1 2 3 4, what is the node? Until you are not getting a node, you cannot this link. You have write one method that give me the node at this position. What is the position at this node? Without node I cannot link. Here I can create the node, new node equal to new node. This is the element, but what is the next? What is the next? What is the next? Next we cannot say null, because our intention was that whatever our linked list, 9 5 1 2 3 12, okay, after this position 0 1 2 3, after 3 is this 3 position I want to new value. So new value we can add here, and but this linkage from here to links come here and then go to the here. So we need a data, this data, so that we can get. So at this position what is the data available? So similarly we need one. method that return the node at a position. So let's return a node and get node at position, at position null. So here we have already one node method, but get the node at position, at position. Okay, now where the error? Okay, we let's key after 4 I want to add 77. Okay, so now you have a 77, but 77 you have to link somewhere in the link list. For linking we need a node where you are going to link. So we write a method that return me whatever the position pass, they give me the node at a position. So how to write the code node at a position? So let us write a code. Let's give, for example, let's loop for loop I less than equal to position, whatever the position we have to just run the loop. Okay, and here you have to just head node your head temp, start from head. Okay, so in this example, whatever the your linked list available you have, you want to specific position data. Let's say I want to this position data. So you can start from a 0, 1, 2. So until this run the loop and figure out this data, right? So here you can say just run temp equal to temp next. Okay, and finally at these positions you will get the node, just traversing from head to that positions, and you will get the specific data. Okay, so let us run here. First you already check the size. Yes, size okay. Get the position data. Just let's print it. We are get kya, whatever the elements you are getting. Let's check it. So here we are passed 4 as element, and we are getting 0, 1, 2, 3. So what the value find? Node at a 3. That means this is the 0, 1, 2, 3, 4. So this is the data we pass at 4. The 4 position we get this data. So at this position I want to add the new value. This value can say, here say in this example we say we want at the 4th position this 77 would be add. 4th position, that means 1, 2, 0, 1, 2, 3, 4, this position. So now you node found, you can make a link, right? Go to the here and just you already have a element available, so just you created new node, just link to position at next, and this position dot next equal to your new node. Now you can link. So in this way you can get specific position data and place. Now you notice you are getting the 77. Just remove this value. So we are past what the position? S out, just this position. S out, what the? Okay, just run it. So you know key at which positions what value you are storing. So you notice that we are passing position number 4. So we started loop from 0, 1, 2, 3, 4. This is the fourth position data, and we are adding after fourth. So you have options. You are adding at the same exact fourth position or after fourth. Just I want to add a fourth position. So you have to run loop less 1. So go to the loop here. Just run less 1. Okay, whatever the position, we started from 0. Okay, or and just run it. So now you notice we are placing new element 77 at a specific position. Here you can pass 4. You can say 0, 1, 2, 3, 4. 4 you are getting the specific element, and after that your next data will be available. So that is your thinking how which at the exact position you want to save, or before or after, whatever the index you pass. So in this way you can add element on a specific position, what the position you want. So generally till now we have covered in the linked list. In the linked list we have any linked list. In this linked list you can add element at the last, or you can add element at the first, or you can add element specific positions, or before a data or after a data. Till now we have only written add method, adding element first, adding element second, adding anywhere. Okay, so sometime this lots of permutation combination you can write, but here you can do some other operation, like I want to remove the element from the linked list. So now this is the linked list, this is the linked list. Okay, we have some set of data, I want to remove the A element. Let's this node I want to remove element 5, I want to remove. Let in the case of 77 we have added, I want to remove 77. So what do you mean by removing element here? Removing element means कि now this node currently jumping here, so this directly jump to the here. So what you can do, whatever node you want to delete, just what the next point, just add the previous one. Now in this way you can drop the node, remove the elements. Okay, so first you have to, whatever the element you want to remove, you find the previous node of this, because this address you have to change from this to this. So let us, like I want to remove my linked list, I want to remove, I just want to paste element, I want to remove element like any element, like I want to 77 remove. Okay, I'll do. So let us go and just write a method void remove, it will take element. Okay, so first you want to remove 77, so you find the element before the 77 so that you can change the link. So you have already written method get previous node and just pass the element and you get the previous node. Next, and you can run it. So you notice we are able to find this 2 node. Just I comment out this, don't need it, this don't need it. Okay, so where I'm getting data, nothing. Let's run again. So let us, I want to removing the element. The first removing that means we need a before address so that we can change the address. So now you get the previous one data here. Where this printing? This, okay, this should be its element. So we know exactly what the previous node. Previous node that should be 2. So you are getting a previous node at 2. So you just want to change this link to this link. So how will do it? How will changing the, let us example here. In this example, we have a 9, then 5, then 1, then 2, then 77, then 77, then 3, then 12. Okay. So now we want to remove this element. So first we find the what is the previous node. This is the previous node 2. Okay, previous node 2, and this is our next node. So already, so how will do? So this is the previous node. Previous node you have to add this, also need this node. What is the next address of this 3? This is the place here. So what this value you just store in this here. So that from the this 2 code jump to the here, not jump to the here. So you need the actual node as well as. So let us say get node at the element, whatever the element you pass. Just check the node you want to remove. So now you have a both node. Note the previous node and current node. Just make a change the links. Now you get a 2 node, previous node and 77 node. Here you want to remove 77. So what you do? Whatever this again, let's key here we have a 2 node linked to the 77. 77 node link have a 3. I want to remove this. So what I can do, whatever the address of this, just replace the whatever address they have contain. Let's this value just copy from here to here. Now whenever traversing from 2, now you jump to this node directly. That means this node is dropped. So whatever the previous node dot next, just put this current node dot next. Okay, so here simple say what I want to do, whatever my previous node dot next, just assign whatever the current node I found, just this value. Just change the relationship, and now you notice our logic is done. We have only need to change the links. So deletion. So now you notice our 77s are removed because you change the link. Now after 2 you just jump to the 77. Now here we change previous node to previous node this 2 dot next, put the node current node, whatever the current node dot next. This is the current node 77. Current 77 already have a address of this 3 point. You can just retrieve here. Now this 2 link to the 3. So this is the simplest way. You can remove any element. Maybe I want to remove the last element, or I want to remove the first element. You can do any operations, whatever you want. Let us example, I want to remove the first. Remove first. Do you know want to remove the first? That means void remove first. And you know first don't need any data, just remove. So you know first is the header. So want to say simply say header. Oh, how do let's think. This is your complete node. This is your linked list, 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 this is your linked list. Currently head pointing to here. You want to remove the first element. So you just change head to next head. Now this is the head node. Always this node automatically remove. Now you start from head here and jump to the last. So simple say head equal to head dot next and done. And whenever you run it, you notice that you removed the first element. Now your first element is removed. Maybe you can remove the last one. So lots of permutation combination you can play here. I want to last. I want to remove the last one. Okay. Void remove last. So you know how to remove last. You know in our link list we have this link, this node to link this node to link this node to link this node link to this. But no, this is your head, this is your tail. This is your tail. Now you just make the previous node make as a tail. Okay, or just set this is the null. Just now your loop only traverse till not null. So in anyhow, whatever the last node you have, just found the what is the previous one and set this is value null. So I know we have already last node in the tail part. Just want to find the previous one. This is the previous node and the previous node set as a null. And now whenever you traverse from head, you are getting the only limited. Last node is deleted. Whenever you set this is the null, that means after that you cannot jump to this node. So you know you have already last node. So say get previous node, whatever our tail node, tail dot elements, and just find the previous node. Now we have a previous node. Previous node dot next, just set null. And now just change our tail is the previous node. So in this way you can remove the last one. So there are lots of options, any element, any positions, any kind of operations you can do. Notice our last element is removed. Here first was removed. So in a linked list, only you have to change the linkage between your nodes. Okay. So if you want to remove first, just change the header link. This is the header link to here first removed. You want to remove the last one, just go to the previous one and set this is the null. This is removed. You want to remove this element, just go to the previous node and just change the link to this node. Now this is a drop. So in this way, first, last, or any element you can delete. Even a specific position data you can delete. Let's see first position, a third position, fifth position data you want to delete. Fifth position, find the position node, the previous node, and get the delete the data. So all the operations you can do, only just changing the linkage. Let us just I want to remove a specific position data. So I want to remove at index. I want to remove at index, at position, at position. Let's say I pass a position like 3, third position. Okay, so I will do. Simply again go here and say void this int position. So again here we have to check the user pass position is actually less than our size or not. So again get a size function and check if size is whatever the positions is less than our size, right? And here you can again what you do if you want to, let's example, let us, this is the node, this is the linked list, this is the link. Let's I want to remove the 0 1 2 3, this element or this element, let's, okay. So what you can do, first you need to find out this node, what is the node at this position, find the node, then what is the previous, this is the previous, and what you can do, just change the previous node link to this one, done. So here you have to find the get node at a position, get node at a position, you can whatever the position you pass, you get the node. And now this is the node at position, what is the previous node, get previous node, whatever node that element, you can find the previous node. Now we have a previous node, just change your previous node dot next to the which element you want to remove, this is the remove dot next. Now this is the removed. Just check it. So here you notice you remove this third 0 1 2 3, you remove 2. So what here you are doing, whatever the here in this case, in this before this was a 5, then link to 1, link to 2, link to 3, link to 12. So what you say, first find the position at data. So what is the position at data, this is position at data. Find the previous one, what is the find the previous one, this is the previous node data. What you say, previous dot next is this address, change the node dot address, what is the this address, this is just right here. Now this your node now jump from here to here. So in this way this element is removed. So very simple, whenever you play with the node, this is very simplest way you can do any operations, right? Even you can do lots of things here, find max, find min, even you can sort the linked list data, so lots of operations you can perform here itself. Let us just I want to sort this linked list somehow, like a function like sort this link, sort, okay. So how to do sorting, as usual, you do bubble sort, insertion sort, any sort you can apply here and sort the linked list. So you already have a header, from header you can traverse and what do you mean by sorting, sorting means just ascending or descending order, as you know in the array data structure, bubble sort, selection sort, you can just use anyone and apply the sorting logic here. Same, the logic is doesn't any check, just uh, get the size, you have already size equal to size function, you can get the size and run loop the same size. And again for sorting need kind of a j loop, just size, just run and just make here your I plus 1 bubble sort, nickel bubble sort, just one by one they are sorting, apply here and you can just take this two value, this position value and this position value, and just check get node at specific positions. So here you can say first time J. What is the J position data? You are getting J node. Okay. And similarly, okay, here your J node data. Let's J node data, and similarly you have to write like generally in a sorting how write code, like if your uh, J this is the -1 and this is the J, let's -1 and J node, and you can just check this node value, this node element is if less than J node dot element, if less than, then do swapping, swap the data between the two nodes. So you write a swap function, just swap these two node, okay, this node with this node, and just take here swap, here just write swap function void swap, it will take node I comma node j, two node, and just swap it. As you sample, take one temporary variable equal to just store I dot element first node, and I dot element equal to just pass j dot element, and just pass j dot element equal to your temp. Okay, temp. This is swapping. So in this way, all the operations here you can place. Simple bubble sort I written. Any sort you can write here, and you notice you will getting the sorted linked list. So that is the flavor. Lots of linked list operation you can do here. Okay. What is happening? 5 1 2. There is no. What happened? Here you say I node data t dot z. Then sorting happen. Just j less than I plus plus. You say this is okay. This is should be greater than first node greater than to swap it. You are getting a swap data. So you are saying first if I minus 0 means 0% data matched with the then swapping the data. In this way you can add some more element and they check your sorting has happened. Just add some more element here like linked list dot add. Let's add 4, add that's 9, add like 29, add like 91, and before sort you can just show the element. Okay, so lots of operation you can perform in the linked list, but if conceptually you know how to use a linked list, you can do each and everything. So now this is the previous, and now you get a sorted linked list. So hope this will help you to know how you can create your own linked list. The basic rule is simple. Just you create list of node, whatever you want to list of node you can create, and make link between this node. This is the linked list, and maintain one first node known as a header and last as a your tail. You can properly make a linkage between this. In someone want to add new, you can just create new linked list. Just change this address to here and just change to here. You want to remove something, just whatever the address here contain, just place here, and now you can change from here to here. Even first, next, last, all the elements you can do. So let us try to write your own linked list and until you're not writing code, might you not feel more comfortable. Okay, so let's play with this. If any doubts, so you can discuss, but let's try to write linked list. This help lots of getting actual understanding what the linked list data structures. Okay, from this note, I would like to say thank you for watching this video.